So welcome back, topic 1.32. This will be part two. So now problem 175, rewrite each of the expressions below twice, once using repeated multiplication and the giant one to simplify, and again by using your new pattern for division with exponents from the previous problem, and then we'll see what goes on. So x to the fourth, so with repeated multiplication, we're going to do x times x times x times x. And then at the bottom, we're going to have a total of 5 x's as well. So that's repeated multiplication. And now if we create the giant ones, you'll notice that we have 4 of those in total. So we're left with 1 over x. So that's the first pattern. The second pattern would be x to the fourth. So we have x to the fourth over x to the fifth. And remember, you're subtracting. So x to the 4 minus 5. 4 minus 5 would be negative 1. And this would be our answer right there. So since both of these problems, right, come from the same simplification, we can say that x to the negative 1 equals 1 over x. So let's see if that repeats again. So problem B, again, using the first way, use repeated multiplication, you're going to get x times x over x times x times x times x. And then again, you have 1, 2 giant ones. And then remember, there's always a 1 left over on top. So you're going to have 1 over and then 2 x's. So that would be x to the second power. And then if we use the second way to do this, that would be, again, we have x to the second over x to the fourth. That's equal to x to the 2 minus 4. And that will give us, again, a negative number, so x to the negative 2. And then on our last problem right there, C, we're looking at x to the 7th over x to the 10th. So again, expand. We're going to have 7 x's on top. And then at the bottom, we're going to have 10 of those. So 3, 6, 7, and then x to the third. And then 1, 2, 3, 4, 5, 6. So we have 7 giant ones, right? So all of those divide out, and then you're just left with 1 on top left over. So this would be 1 over x to the third. And then again, using the repeated pattern, so x to the 7th over x to the 10th, that would be x to the 7 minus 10, and that would be x to the negative 3. So again, that's equal to x to the 1/3. And then over here, I forgot to say the same thing. All right. So now investigate problem 176. Investigate x to the m over x to the m. What is its value? And then how can you rewrite it using a single exponent? What new conclusion about x to the 0, I should say x to the 0 right there, can you draw? And then again, let's see what happens. All right. So again, if you guys think about this, right, if the x is any number, let's say it's 3, and then m is 2, so 3 squared over 3 squared, right? That's pretty much 9 over 9, and I know a number divided by itself is always equal to 1, correct? So you guys can try this with any combinations as long as x and m are the same numbers, both on the top and at the bottom. So if you guys have, right now, so we can say that x to the m over x to the m equals positive 1. And then if we rewrite it using the pattern that we learned in problem 174, right, which was x to the m over x to the m, it's a division, so I can rewrite this as x to the m minus m. Now, if you notice here, one of the things that happens is that if we subtract the number minus itself, right, 2 minus 2 is always what, right? It's 0. 3 minus 3 is always 0. If you always subtract the number minus itself, you're always going to get 0. So this would be equal to x to the 0. And this is a very important conclusion that you guys have to connect, that x to the 0 is equal to positive 1. So any number, this means that any number raised to the 0 power is equal to positive 1. There is one exception. You cannot raise 0 to the 0. Okay, so that is not equal to negative 1. I mean positive 1. So any number with a 0 exponent, or any base, right? Any base, right, with a 0 exponent is always equal to 1. Right? So remember, there is an exception, and make sure you guys write it on your notes somewhere. Except 0 to the 0 does not equal 1. All right, that's the only exception. And then problem 177, expand is needed. So in order to use the giant ones to rewrite each of the expressions below without any negative exponents, okay, so we want to get rid of those negative exponents. So remember, one of the easiest ways you guys can think about this is the negative exponents is if it's at the bottom, it's going to go back upstairs. So that will be 18x squared y to the first power, and then over 30x to the fifth. And now we can start using those shortcuts, right? So first, you guys should always simplify the numbers. 18 over 30. Remember, this is 18 over 30 is the same as 6 times 3 on top. That's 18 over 6 times 5. Those are the factors. And then times, we have x to the 2 minus 5, 2 minus 5, and then times y to the first, and it's by itself, nothing else. So we simplify here. There's a giant 1 right there, right? And then 2 minus 5 becomes negative 3. So that's 3 over 5 times x to the negative 3 times y. And always be careful. We want to make sure that you guys rewrite everything with positive exponents. So put a 1 under this and then just flip it over. So that would be 3 over 5 times 1 over x to the third times y. And then once again, put it all together. You're going to get 3y on top over 5x cubed. Again, you guys, if you already picked these patterns up, you don't have to be splitting everything up like I am, and just making sure that everybody's getting the same lesson. So that way, if you're still struggling, there's no worries, all right? Now, in problem B, we have negative 5 times x to the negative 2y, and then times negative 2x to the third times y to the negative 2. So the first thing you guys want to do is put the numbers together. Let's group these two. So that's negative 5 times negative 2. So let's group those two first. And then let's group the x's. I think there's a mistake right here. I think this y should be at the bottom right there. So this should be times x to the negative 2. And then since we're multiplying, we're going to be adding the exponents from the x's, plus 3. And then times y to the first, right, from over here. And then plus a negative 2. So simplify, a negative times a negative is a positive 10. And then we have negative 2 plus 3 is x to the first. And then 1 plus negative 2, that would be negative 1, right? Subtract. And since we have a negative exponent, remember, flip that one over and that's it. So you're going to get 10 times x over y. And that's your final answer. And then the last thing you want to look at right here. So again, combine. Let's put the numbers together. There's a multiplication here. And when you guys are multiplying fractions, remember you just go straight across. So we can regroup these since multiplication doesn't, like the order doesn't matter in which you multiply things. You're going to get 15 over 45 times 1 over x to the second times x to the negative 3. So again, simplify 15 over 45. That's 15 times 1 over 15 times 3. And then times 1 over x to the 2 plus negative 3. So that's our exponents, remember? So here we're going to have the giant 1 is right there. We're left with 1 over 3. And then 2 plus a negative 3 would be 1 over x to the negative 1. And again, since we have a negative exponent, take it to the upstairs, right? If it's upstairs, take it downstairs. If it's not, if it's downstairs, then take it upstairs. So backwards. So now we're going to take it upstairs and we're left with x over 3.